Hello friends, welcome to AMT, Automotive Embedded Technologies. Today I would like to talk about an important and an interesting topic of automotive industry where the current vehicle manufacturers are working towards and the automotive industry future is looking towards is ADAS, Advanced Driver Assistance Systems. So we will look inside of ADAS technologies, what kind of infrastructure has to be used, and what kind of vehicle functions are involved, and what are the levels of ADAS, and we will discuss more insights today in upcoming slides. So let's go to the next slide. So this is a overview that what are the points that I would like to cover in this video. And yeah, so first we need to know what is ADAS. So what ADAS stands for, what does exactly advanced driver assistance means, and what is the importance of ADAS in automotive industry, and why this ADAS technology has come up and uh, required for the future vehicle technologies. What is the reason behind? And what are the key elements and sensors or electronic components are used, and how does ADAS work in reality, and what are the levels of ADAS, how many levels of ADAS we have from automotive standards, and what are the real-time applications that currently we are already seeing in few vehicles, and also we will see so many of uh, improvements in vehicle functions in upcoming years. And at the end, what are the current limitations of ADAS? We will discuss more insights of these topics in upcoming slides. So let's go to the next slide. Yeah, so ADAS stands for, so the abbreviation of ADAS is Advanced Driver Assistance System, and this is a technology, automotive technology is built with several coordinated sub-technologies of the system which will help the car users, drivers operate the vehicles with safety and security, with more comfort provided, I would say. So where driver interventions are slowly getting decreased, and a vehicle itself has ability to understand the environment using different kind of sensors that we will discuss in upcoming slides, and how these sensors understand the environment in different environmental or weather conditions or road situations and react upon. So this is where we see the more comfort and safety to the driver, and how the security is also involved in this ADAS era. Coming to the official studies, so far that coming from a different kind of automotive regulatories, I would say. It is observed that there were multiple serious and severe car accidents were caused by mostly human errors, like less road awareness during driving, and uh, for example, if you see, if you are driving in several countries which has more road infrastructure, very good road infrastructure, but if the road awareness is not well, and when you are driving really on high speeds in different weather conditions, this is really a safety critical uh, situations, I would say. And this is just not a damage to the car or the user, but also to the outside environment of the road infrastructure, also the other road users, pedestrians, and other vehicles which are running on the roads. So it's a huge damage to the total environment. So to avoid this, we have bought the ADAS technology in the automotive industry with respect to several sensors involved and several outside technologies, a GPS, cloud, data sharing between different vehicles, service centers, and etc. Okay, let's go to the next topic. So now we will see what is the main importance of this ADAS. So this is mainly developed to support and reduce, also avoid various kinds of traffic accidents and damage to the road users, as we just spoke before. So by integrating several technologies, the help of navigation unit, automated detection techniques with cameras, radars, lidars, and ultrasonic sensors, which are currently installed in a passenger or commercial vehicles, I would say. Also, this includes kind of a collision avoidance systems of where the vehicle automatically takes a turn when there is a dangerous situation ahead in front of vehicle that may lead to a collision. So the major purpose is here to reduce the driver workload while driving the vehicle, also the stress to the driver, to give more comfort and safety driving, I would say, in other words. Also to improve comfort and convenience. Yeah. Also to facilitate the transition to fully autonomous driving. So we have different levels of the driving's level. Driving standard levels, so it's ADAS levels. So we have from level 0 to level 5. So level 0, 1, 2, 3, 4, 5 are 6 levels, where for each level we have a certain defined limitations where driver really need an intervention or partial intervention of the driver when he is driving the vehicle, or full intervention of the vehicle directly and no need of real driver driving the car. The system itself takes care of everything. So there are few levels that we discuss in coming slides, and this can be only achieved when we also improve the vehicle's awareness of its environment, how to use the functions by the driver, and ability to respond appropriately to the real situation of the driving dynamics within period of short time. So I would say this, I can divide these to 2 points. For example, if you're driving with the vehicle which has ADAS level 0 or 1 or 2, okay, and driver must have an eye on the alerts given by the system and take back the control when system feels difficulty to understand the environment, like some blockage to the sensors or whether it's too rainy or too foggy or etc. And another part, the ADAS system itself can respond appropriately when the system is a level 4 or level 5 or of course level 3. The driving dynamics is directly taken care by the system. Most of the part from system and reacts on very short period of time is very important. Timing is very important for the ADAS execution of the functions. For example, if you take a pedestrian is coming in front of the car and the car is driving with 50 kilometers per hour and we need an emergency braking, maybe less than 500 milliseconds. Within a second, anything can happen, damage to the road user. So the the periodicity, the time taken for the complete function execution is more critical here. It need to act as a superpower and get ability to avoid the danger. And so it's I would say this is, in other words, It's a very sensitive time critical system as well, ADAS, which has more components, more sensors, more computational units. It needs a lot of accuracy on the system components, I would say. Let's go to next slide. What are the key elements and what kind of sensors that we use in real ADAS systems to support the functions and make the system performance better? And um, you know, and these components must work together to perceive, to detect, understand the environment surroundings, and react upon in the real time, and give an assistance to the driver when there is an issue. And so here we have the major list of components. I would say sensors and other electronic control units are involved here. Also vehicle network. So for example, if you say if you go by list, we have cameras. So we have several kind of cameras in current ADAS systems where it covers the frontal driving trajectory or with the surroundings. You need to install more sensors or cameras, like for example rear view camera cover the rear part of vehicle. Of course, the side cameras which might be installed in the mirrors that we are seeing nowadays in some latest cars of level 2 or level 3 ADAS levels, and has also cameras in the mirrors, so where you will get the complete 360-degree view covered by all these front, rear, and the sensors um, connected to the mirrors. So where you see the 360 degrees coverage by these camera systems. And also this is very useful during parking of the vehicle. I think there is a function called bird eye view where you see the vehicle from top view when you're parking the vehicle, and which is um, very useful when you're doing kind of a parallel parking or other kind of parking um, situations. And coming to radar for long range object finding, of course, we can't see an image of object in front of the car while driving, but we see with this technology, with some ecosystem, uh, the shape of the object and to determine what kind of objects are there and etc. And coming to lidar, this is really defined for the short range and mostly for the blind spot corners where the other sensors of the cam as a vehicle, either camera or other rear view or front view or ultrasonic sensor cannot see. This part is covered by lidar units. The pictorial presentation will be in upcoming slide and how this is covered. So all surroundings of the vehicle with using all sensors. Coming to our next ultrasonic sensors, we use, as you know, for parking and finding the objects just a couple of meters in front of the car as well as back side of the car, because for mostly without camera we use ultrasonic sensors for rear view or frontal view sensing while parking the car. I'm coming to control electronic control unit. As you know, we need a lot of high computational system and very good vehicle architecture to execute, to understand the environment, to process data coming from sensors, and to execute in less span of time to provide actual function output in real time. And coming to next, GPS navigation systems. GPS and navigation systems are playing also a major role to understand the traffic signals, to understand that the road infrastructure like speed limits, traffic lights, and other road regulations or standards that will be followed in different geographical regions of the earth, and are taken as an input to the system. And understand infrastructure. For example, if there is a speed limit called board mentioned as 50 or 30 kilometer per hour, and then we have to understand, oh, there is a speed limit that we have to follow. Then system has to adapt the speed and control the vehicle speed. Also, when there are certain pedestrian paths, so for pedestrian paths we have several signals, several indications on the roads, and those has to be detected, and then automatically the vehicle has to come down to the lower speed and maybe must stop the vehicle when a pedestrian is really crossing. And next, coming to in-vehicle network, so we have different kind of network technologies inside a vehicle, that all electronic control units, sensors or actuators communicated uh, using like CAN bus, Ethernet bus, and etc. Coming to software part, so apart from hardware, infrastructure, everything, software plays a major role while doing this computation, processing the digital inputs coming from sensor, and understanding uh, the sensor inputs coming from the environment, and execution of the algorithms in meantime, and providing the output to the real ECUs which are controlling the dynamics of the vehicle. And the final one is display and human machine interface, HMI. HMI plays an important role when there are some issues with the system, that if that cannot detect some environment due to weather conditions or so on, will give back the control to the driver, and driver must see and understand what kind of alerts he is getting in the instrument cluster, as a pop-up or as a sound and so on, and must be ready to take back the control. So these are the key elements and sensors, I would say. Coming to next slide, we will look on how does exactly ADAS works. So as we spoke, lot of sensors, lot of ECUs, and etc. So the integration of all these sensors and the technologies inside to achieve this perception and vehicle surroundings, we need more data processing, decision making, and execution of operations. I think we already discussed a bit before slide. So I would say the following is detailed working principles on top level. Perception is detection, understanding environment. Second one is data processing and sensor fusion. So data processing is transceiving of data between different units. And sensor fusion is, of course, we have several sensors connected in a car, in the different places of car. Maybe one sensor or couple of sensors may provide malicious inputs or wrong inputs due to their malfunction of the system, and this to avoid confusions while taking decisions by the electronic control unit. When we get, for example, we have five sensors, and two sensors are giving there is an object, and two sensors are giving there is no object, and third sensor is telling it's like 50-50% of the data. Then we have to fuse this data coming from five sensors and understand, are we getting the real uh, valid data from the environment, or are there faults with any specific sensors or units? So we need to uh, understand this. We need to understand from the different sensor units, combine this data, nothing but fusion, sensor fusion, and then process the output to brake a vehicle or to increase or decrease the speed and so on. This is called also a decision making and control. So when you make such decisions are very crucial. If you don't need an emergency braking, but if sensor gives some wrong information and says there are several objects, and if you apply a brake, then there is a big damage to the road users. You as well as the one who is coming from behind can hit the backside of the vehicle. And also based on that, there should be accurate controllability. For example, if there is a pedestrian and if you're coming from 50 or 60 kilometer per hour, and there must be an emergency braking applied, and which ensures the road user cannot get hit by the vehicle. Okay. And coming to HMI, I think we just spoke. HMI is where you see all alerts, where you get some sounds, alarms to take back the control, or to also to understand if there are some issues with the function. Might be real issues, might be faults in the system. So the driver must be looking and should be able to understand what are those inputs given by the system. And coming to the fifth point, system monitoring and learning. So system monitoring and learning is once there are set of sensors and actuators and other technologies are installed in the system, and the system must learn itself with the real time data. How we get, for example, there are several vehicles nowadays running on the roads, and they are testing a lot of ADAS features. So this time we collect lot of data during testing, and we analyze, we process the data, we find the issues, and we try to find in what kind of environmental or road situation these issues has occurred, and we try to find where are the limitations, what are the drawbacks or issues in the system, maybe software or hardware or whatsoever. And then we have to learn uh, um, the issues from these scenarios and make the system stabilized and improvise the system for the better output. And coming to the system integration of vehicle control, yeah, so it's just not limited to the single vehicle. Nowadays, we have other technologies called V2V communication. So there are several cars going on the road, and let's say one, two, three, four, five cars. The first car, what is has been observed of environment condition, either a crash, has an issue with the road, or there is a problem with the road infrastructure, or etc. detected, then this must be informed to the other road users which are coming in the backside. For example, the third or fourth car on the same road in the same direction will really help the one who is coming behind to understand the environment well better, and then uh, uh, control the system, control the vehicle with the safety inputs, so that it need not be travel longer, and then you know the environment well before by this V2V communication. This is one of the example. And control the vehicle accordingly. So these are the major um, principles, I would say, and where we get the consolidated uh, output of the system with support of lot of infrastructure, what we spoke about. Coming to the next slide, what are the levels of ADAS? So we discussed also this in my first video on top level. So now we go a little bit detailed. So now I have divided these levels from 0, 1, 2, 3, 4, 5. This is according to the SAE, Software Automotive Engineering Standard. Sorry, Society of Automotive Engineering. And here, uh, uh, let's say we divide the job of the driver or the vehicle from level 0 to level 5. If you come to level 0, we don't have any automation. The complete driving in charge is driver. And vehicle doesn't have any sensors or actuators or any intelligence to control the vehicle dynamics. Coming to L1, of course, here it's as it is as a level 0, but driver could get some help, basic help for braking or lane keeping support. For example, if you are traveling in different lanes, level 1, level 2, level, you are crossing between different lines, L0 or L1 or L2, for example. I mean, not the driving levels, I would say line 1, line 2, line 3, and so on the roads. So without your intervention, if the vehicle is trying to go to from lane one lane to other lane in other lane in high speeds like 100, 200 or 150 or 200 kilometers per hour, so there's a chance of crash between the cars traveling in same direction in two different lanes. I mean parallel lanes or adjacent lanes. So to control this, we need to understand if there is a lane change without driver intervention by steering angle or without showing an indicator, etc. So driver gets a jerk in the steering wheel if he is not intendedly going to left or right from one lane to other lane, and there's a chance of a crash. So driver get a basic support or notification. Coming to L2, um, during the same situation, the vehicle itself can drive or follow the driving the car location of the in between the two lines must be adhere to the two lines. It's like the car will be centered in two lanes and will be traveling ahead. Even if you try to go to the left side or right side onto the lanes unintentionally, automatically the vehicle comes back to the middle position of two lanes, and then vehicle will be driving as usual with giving alerts that your the vehicle is trying to go right unintendedly. So driver the steering wheel itself get controlled by the vehicle components and get adjusted to the in between the lanes of the road. Also little bit braking, little bit braking during if you enable the functions like cruise control or adaptive cruise control systems by adapting the uh, target object speed or by considering the speed limit given by the driver. Coming to L3, conditional automation. Of course, here there is 50% of driver intervention is required, but not all the time. The vehicle itself can take full control over steering, accelerating, braking under certain conditions, like while maneuvering or etc. But still, driver get an alert if there are some situational issues or environmental issues that system say take back this control, and yeah, we must be driver must be able to take this control to himself. And coming to L4, driver can still leave his two hands or two legs. He no need to accelerate. He no need to brake. He don't need to change the direction. Of course, when he want, he can take, but still he can just put the navigation and then say, I want to travel from A to B, and the vehicle itself will be controlled in such a way that the driving distance, the driving maps, navigate the navigation support, GPS support, sensor support will be most included here, and then high automation can be achieved in this. Coming to full automation, this is a final level that where you driver no need to sit in a car. The car just can travel without a driver. I think nowadays we can see a lot of videos. Maybe I can put some links in the comments that you can go through these videos and understand how these levels really differ and how level 5 really works. We can say autonomous cars. Some countries are having autonomous taxis that where just you book a taxi by your mobile and then it will track your location and get it stopped in front of you, and then you can just take your seat and enjoy the drive. So it will understand the 360 cameras, radars, ultrasonic sensors, everything, and all the vehicle infrastructure, and it will uh, take complete drive control and drop you at the preferred location. So here I would say these are the main levels of ADAS from L0 to L5. Coming to next slide. Yeah. To real-time applications of ADAS, we just already spoke few functions. Now we will go a little bit more and understand which function is used by which vehicle technology. For example, if you see lane departure warning and traffic sign recognition are more involved with the sensor unit mentioned here, which is nothing but we will achieve by radar. It can be a low range radar. Coming to adaptive cruise control, where we detect the targets in long range and we adapt the speed of uh, 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 the front car, and then we maintain the same speed or set speed what is given by the driver as it is. Also, driver can set distance, what how much distance can be maintained between your car and your front car to avoid the dangers. So here we use long range radar LRR. And coming to here, we see emergency assist, braking assist system, automatic emergency brake assist during the pedestrian travel, during the collision avoidance to avoid the collisions, etc. We use lidars here. So it's a low range radars. I would say the lane departure warning and traffic sign recognition more are done by the camera. I forgot to mention this is not a radar or lidar, but it's a camera that detects the different pictorial presentation of the traffic signs like speed limits, local road regulations, rules, and lane departures from one lane, going one lane to another lane, etc. This is done by a camera, front camera, I would say, the camera which is installed in front of the car. Coming to the cross traffic alert, we have mid-range radar, MRR. So we have a low range radars, also mid-range radars, where this covers the major blind spot of the system, I would say. Also, it includes cameras, but this is the main blind spots or corners where mid-range radars are taking care of this cross traffic alert. For example, when there is another vehicle coming from here when you're traveling. So like this, when you're trying to come to this lane and this takes this takes major role and gives input, hey, there is a vehicle in this line and be in this line only, for example. Coming to surround view camera, of course, we have several cameras, three or four cameras, two cameras installed in this and these mirrors, and then we get the surrounding view of the car. It's like we call it as a 360 degrees bird eye view, and it's very important for certain kind of parking situations. Coming to remote access, I think we have GPS, global positioning system, is a technology that we use. Coming to the rare collision warning and cross traffic alert, also mid-range radar. This is, uh, I think also we have the cross traffic alert from back and front, and also it provides the rare collision warning when you are trying to applying the reverse gear and trying to move little bit back during your parking or during your drive, etc. And intelligent parking assistance system is complete ultrasonic radars, nothing but ultrasonic sensors. The parking guidance, I think 3 to 4 ultrasonic sensors here and 3 to 4 ultrasonic sensors will be used here. And the rear view collision also can be used sometimes by the camera installed here as a rear view camera. Coming to blind spot monitoring system, this is by also the mid-range radar, as I said before. So these are the main components, I would say. Video camera which is continuously taking the video and monitoring, and the signals are passing between the camera and the vehicle control units. And lower range radar, mid-range radar, and GPS and etc. are the main sensor units, and also, sorry, ultrasonic sensors are main sensor units which will provide important inputs to the electronic control unit as the computational systems, and they'll execute the system inputs on time and execute the functions of the vehicles accordingly. Coming to next slide. Apart from the features, the functions, comfort, safety, and security are getting from ADAS, we have certain limitations of this technology as well, or using this technology in cars. The first one is system accuracy and inconsistency. Sometimes a system may have some difficulties functioning in different environment conditions like low light, low sunlight, and system cannot detect certain signals on road, traffic signals on road, traffic rules on road, and different weather conditions like snowing, more temperature, or more rain, or more fog, and etc. So these are the main drawback, and this can make difficulties for sensors to detect the objects. For example, camera cannot see if there is a high fog. Sometimes camera cannot see the traffic signs, and also the surround view cameras cannot provide the quality of the data. Also cannot track the objects accurately, and leading to sometimes it assumes there is an object in front due to the unclear vision, and then provide a false alarm or some missed warning. Sometimes there's some warnings can be missed. Sometimes it can give false alarms. Sometimes it won't give an alarm if there is a real problem, a real object in front of the vehicle. And coming to the next point, hardware and software issues. So ADAS systems rely heavily on several hardware and software components that we discussed already. So while processing this sensor data, while processing this data to algorithm, sometimes software can find difficulties. Also, sensor calibration, self-calibration of the sensors can go wrong during each vehicle restart or fresh drive. Some software bugs also can come during the program execution because there's high computation of data is required here, and a lot of transaction between the cloud, the GPS, navigation, local data coming from sensors has to be analyzed. The data must be fused and then provide the output for the system. Sometimes can go wrong and the output cannot be on time. So this will lead to system malfunctions, unintended driving behaviors, and this will these issues can be minor nuisances to the road users, also can make more severe faults, damage affecting the features as well as the road users, I would say. Coming to road infrastructure. So this is a major disadvantage, I would say, limitation that if the road infrastructure is not well. So as we know, different geographical locations of the earth has different driving conditions, driving rules, traffic signs, road users. Road users can be uh, 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 a best example in some countries where you don't have proper road infrastructure. And coming to some rural or urban areas of the cities also has very less infrastructure. So this varies between different countries and different regions. So this plays a major role, and will, for example, if you don't have traffic signs at all, and system don't know what kind of speed it need to be maintained by default, then driver should look for what kind of speed is required in this condition. System cannot decide always high speed or low speed or etc. Also pedestrians. If you don't have a pedestrian signal and there is a pedestrian path, and system sometimes cannot understand what is this traffic sign and say to the driver, hey, there is an issue, and try to take over the control, and driver has to take over. So these are indirectly talking about the levels what we spoke before. So I would say, friends, this is the more insight of ADAS infrastructure used and what kind of features, what kind of sensors, and what are the limitations, etc. I hope you enjoy this video. Yeah, and I would request you to provide your, if you have any questions or comments, it will really help me to understand, to improvise the data what I am providing from past videos. And yeah, at the end, knowledge is more reachable when you really like the video, share this video, and subscribe to my channel. And stay connected, guys. And I will provide the links for um, I, Instagram or Facebook. Also, we can connect there and talk about many queries if we have. Also, I would appreciate your requests, and I can also provide certain knowledge-based videos also on those topics. So stay connected, stay tuned. Thank you very much for watching this video. Bye.